Hi, I want to show now paper 2 of my PhD thesis that it's titled A Conflict Between Traditional Flood Measures and Maintaining River Ecosystems, a case study based upon the river Lardal in Norway. It contributes to the objective one of the thesis, illustrating how high precision LiDAR can enhance 2D hydraulic modeling for flood mitigation assessment in combination with minimal environmental impact. And we'll see more about this now, but it also wants to illustrate that we as a society might have a conflict between the traditional flood measures, so the measures that we are used to, such as channelization and ribbon walls along the channel. We will see more about what this means and maintaining river ecosystems. So, because many times we change the river, and this is super common in in most of European cities, for example, that we channelize the river so it has more capacity to protect the city from the flood, which is a fair reason, but at the same time we are completely changing the environment and also for fish habitat and for micro habitat, macro invertebrates or also the vegetation. And this is a picture of King Harald of Norway fishing in this actual river. So what we wanted to show also is the importance of maintaining river ecosystems because they do provide a service for the community and for our culture, for our food, for the environment, for many things that we could also quantify in an economical way and as a service for us. So in this river, we also have very good LiDAR data sets, very precise. So that's what we want to use, the LiDAR data to assess this impact. We can see here this river Lardal and the town of Lardal, sorry. We can see that's steep fjords with very steep mountains on the side. And this is the first model we did. In normal flow, you can see this island here. It's this island that we are showing in this drone picture that we took during field work. And we did the model in current situation. We did a model with flood. I'm going to change myself to here. And we also did the model for with the proposed measure by the authorities and also how it is protected from the flood. So what we see here, how is the river now? The natural river, but the town gets flooded. And also the measures that the authorities are proposing that are channelization. You can see the river changes completely, but the river is protected. But in this situation, the fish habitat will be gone. All the existing gravel bars, the different velocities, the different pools, all this variability of the channel will be gone. So, okay, we want to find, is there something in between where we can save the town and at the same time save the fish habitat? These are the proposed measures by the authority, and this is very typical when we talk about traditional flood measures. We are talking about this channelization, that is changing the riverbed. So that's what they were proposing, dredging, so taking and giving more capacity to the ground, and also walls in along the river. The dredging increased the river channel capacity. The walls stop the water to go to the floodplains. And there is a trend in European rivers to stop doing this kind of measures because they change completely the environment. The dredging will change the riverbed, the gravel bars and everything, but the walls will kill the floodplain's habitat, which is also an habitat. In this case, it's maybe justified because we have already a town there. But in areas where we could keep the floodplains, where we could keep the plains for flooding, this is a natural environment that provides water for the vegetation and is the actual equilibrium of the system being flooded sometimes. So if this is not creating a damage to the community, that's something we should not stop from doing. So this is the model that we did for the low flows. And we can see in the current scenario, the variability. We see there is depth areas, more than 3 meters pools, but there is also shallow areas that is less than 50 centimeters. So that means the habitat is both for the small fish and for the big fish. And having this diversity helps the fish to move from one environment to another one. But in the after the proposed measures, we observe that the channelization affects a lot this diversity. And we can see that the depth is reduced from 6 meters to 3 meters and the velocity from 4 to 2.5. We also use the Shannon Diversity Index to quantify the decrease in depth from 2.4 to 1.4 and in velocity from 1.9 to 1.7. So this give us a really visual information of how is the river now and what is going to happen. And having this data, having this river bathymetric data in combination with the spawning areas that were measured before by another report, give us a very valuable information to say, okay, look at how the river is now. Look at all the spawning that is there that combines deep pools with shallow areas and give us some force and to try to keep it. So what we did next was looking into the flood scenarios. Here there are three different simulations. First, in blue, the current flood. So everything that you see in blue, the largest floodplain, is how it is the flood now for the 200 return period. And the second we did is the flood with wall and dredging. The flood with the walls and the dredging that the authorities are proposing. This is what you see in stripes. Okay, so that means that all the town is protected. All this area that doesn't have stripes, it's protected, and also this area here. While I'm gonna stop that. While we also did a model with flood with wall and no dredging, no channelization wall without dredging. And what we saw here is that the town is protected, but this additional area in points, you see the yellow points, will be still flooded. This, anyways, is agricultural land. It's agricultural land that if it is flooded in once every 3 years and we can let's say, put some measurements and some support for the people that are running this farmland, maybe it's something that we can give up in order to save all the river channel, because actually fishing is a bring support for the community in this town. So, what we could conclude from this simulation is that without dredging, the additional flood extent will primarily affect agricultural land, while the urban core of Lar del Sore will experience a similar level of impact. Also, I want to point out here that we are only evaluating how is the flood now, what the measures by the authorities were at the moment, and we propose something in between. I want also to acknowledge that flood measures shouldn't go only a local scale, but look, okay, what can we do upstream? What can be watershed solution? Can we decide to flood an area that is upstream, maybe by flooding farmland? Maybe we can use dams upstream to regulate the flood, because if we know a flood is coming, we empty the reservoirs in order for the dams upstream to get all this new water. But in this paper, and for simplification, we are only looking into these three alternatives. So what we also measure is okay, we have the pre-dredging channel profile, and this will be the water surface elevation pre-dredging with the wall. If we do dredge, we have the post-dredging channel profile, and also the water surface elevation will be decreased post-dredging. And this will be the volume dredge from the riverbed. And this will be the additional wall height and the additional wall volume needed pre-dredging. This way, we wanted to do an economical study of both measures, evaluating, okay, how much costs the dredging, but how much costs the additional wall. We compare these two, And now I'm not going to go into the numbers, but we show that the alternative scenario, so ours without dredging, protecting the environment, protecting the fish habitat, is 2.16 times more cost effective than the initial proposal. That means that this measure of dredging will be very costly, but also damaging the fish environment. While if we do a little higher wall, we will save the fish environment, but we also save money. So that was a good point also to get the people and the stakeholder with us into this protection. Also saying a subsequent report evaluating various mitigation strategies, as we were saying before, like more multi-alternative scenario, including dredging, tunneling, site barriers, and no action, identifying a combination of flood barriers and local protection measures as the most effective solution. So another report from another company identified like doing the walls with the local protection measures was the most effective. So no dredging will be included in this section. So to sum up with this paper, I want to say that, okay, we found that LIDAR data can be really good to have an overview of the fish habitat that is available for us or for the community or for the ecosystem, but also help us to evaluate these different measures. And this evaluate, for example, the diversity that we could find in this stream. Yeah, this is the results, and I'll continue in the next video to paper 3. Thank you.